we will see some of the problems in first order kinetics. What are the problems that can be asked in first order kinetics? Once again, what is the first order kinetic equation? K1 into E1 is equal to 2.3 into log of A naught by AD. This is the equation. It is not derived from the general equation because it is not applicable to this one. And another is the relationship between the T75% and the 2 power n minus 1 plus 1 into T50 conversion. And you have already seen that 75% effective 50% is nothing but 2 into G half. This is another type of it. Therefore, if 50% is given, 75% can be calculated, or 75 is given, 50% can be calculated using only these. And there is no variation in the T of value as the concentration changes, therefore no problem would be possible in that one. Here, which type of problems can be asked? Here, K1 with the red constant, time taken, not T1, time taken. This initial concentration generally given a constant. Therefore, what is the amount left? If amount left is calculated, you can calculate the amount reacted can be calculated. Therefore, 1, 2, 3 variables are there, and 3 variables you can be given any type of question to and this is a direct substitution. Generally, no problem would be appearing because it is the easier one. Therefore, it is reserved for JAM examination. And 2 set of data over here. 2 set of data means what do you mean by 2 set of data? That is, for this conversion, this is the time taken. What is the time taken for another conversion? A to 2. Therefore, you have to make use of this equation 2 times, and such problems can be asked widely in the CSR examination. And we will see the formula to accordingly. First, we take down the and the amount of amount left of the how many new number of half-life periods. It is given by the formula AT is equal to A naught by 2 nu. Nu is the number of half-life periods. This type of problem is also asked. Take down the first the simplest problem. Calculate the fraction of the reactant left. Fraction of the reactant left after whatever if the half-life time of the first order reaction is 10 minutes. After 1 hour, the half-life time of the first order reaction is 10 minutes. And you can apply this equation. Here, half-life, you can also apply this type of equation. When will you apply this type of equation? When will you apply this one? And see that one, what is the time given for this? What is the calculate the fraction of the reactant left after 1 hour, 60 minutes, okay. And what is given? The T half of the reaction is given as a first order, 10 minutes. Therefore, the time left 60 minutes can be converted into equivalent to 6 half-life periods, isn't it? If the time required is a multiple of the half-life period, you can make use of this equation very easily. If it is not a multiple of the half-life period, then you should go for using this type of equation. How to use that type of equation? We will see it shortly. Therefore, what is the time amount left of this one? How many half-lives are there? 6 half-lives are there. initial concentration, let us assume A naught. Therefore, 2 power 6 equal to the amount left. What is 2 power 6? 2 power 3 into 2 power 3. You can write it as 2 power 3 into 2 power 3. 2 power is 8 into 8 equal to 64. Therefore, 8 is equal to A naught by 64. 1 by 64th amount of A naught is left over. What is the amount that is reacted means subtract. Say if you take 100% of the A, 64% is reacted, the remaining is 36% is remaining. Or in terms of fraction, how much is left? If you take initial concentration as unity, the fraction left is this much. Therefore, reacted is 64 divided by 64 minus 1. I'm sorry, 1 by 64. The remaining is 64th fraction. Therefore, what is left? 1 by 2, 1 by 2, 1 by 8, 7 by 8. How much is reacted? It is left. Therefore, reacted is 1 by 64. Reacted is how much? 63 by 64% is reacted. 63 by 64% is reacted and the percentage, the fraction is reacted. So we now take from the question. If the half-life of first order reaction is 15 minutes, find the percentage of reactant consumed. Percentage of the reactant consumed after 1 hour. After 1 hour. Whether we have to make use of this half-life period or usually go to this one, all are depending upon the time limits given. Here the time limit for the completion reactant given is 1 hour. That is equal to 60 minutes. And the half-life is given as 15 minutes. Therefore, how many half-lives are there? 4 half-lives are there. After 4 half-lives, how much is left? How much is left? Then what is the fraction of the one? Fraction is given. If the fraction is given or percentage is given, percentage is R. Therefore, after 4 hours, the amount left is AT is equal to percentage asked means A naught is may be taken as 100 and 2 power. How many half-lives are there in 60 minutes? 4 half-lives. 2 power 4. 2 power 4 is nothing but 60. Therefore, the amount left is equal to the amount left is 100 divided by 16. It will be 6.9642 by so much percentage left. But what is asked? Consumed. That is amount reacted. The rate is nothing but A naught initial concentration minus amount consumed. Initial is 100%. Left is equal to 6.25. Therefore, what would be the value of X? X is equal to 100 minus 6.25 equal to the amount reacted is 93.75. You can make use of this type of equations for calculation. Or otherwise, in the first order reaction, the half-life period is independent of initial concentration. Therefore, you can make use of another thumb rule for this. Here, how many half-life is present in 60 minutes? 4 half-life is present. Therefore, initially let us assume 0%, 0 half-life. For 1 half-life, 50% would be there. For second half-life, easily 50, 25. For third half-life, easily 50, 25. And fourth half-life, easily 6.25. This amount will leave. Therefore, what is the amount consumed? This can also be done for the first order problems, not for other problems easily calculate in this way. If you understand this, you will go for the next type of problem using this half-life period. Given A giving product, first order. A giving product, bracket to the first order. B giving product, once again another first order. And concentration of A initially to the concentration of B initially 3/2 in the ratio. T half of A is given as ln2/3 and T half of B is given as ln2/2. Calculate the value of concentration of AT by concentration of B at time T after 3 half-life period. 3 half-life period of our half-life period. Half-life of A. After 3 half-life of A. Option A is equal to 0.75, B is equal to 0.62, C is equal to 1.2, D is equal to 0.42. What is the correct answer? For which, how to approach this problem? You are asked to calculate C of AT by C of BT, and it is given that A is giving the product, and it's a first order. For first order, the concentration is left common, and you have to calculate the concentration left after 3 half-life of this one. And concentration CT is equal to the initial concentration. Initial concentration by 2 nu we have given. The concentration of AT, the reagent A, T is given by initial concentration of A is given as 3 in the ratio 3, or you should just put as a initial concentration of A by 2 power. How many half-life of A? 3 half-life of A, therefore 2 power 3. Similarly, you have to calculate what is the concentration of B after time T, that is given by the concentration, initial concentration of B, and 2 power the half-life of B with. But it is given only 3 half-life of A only. How much amount of half-life of B is there? You have to find out how much 3 half-life of A is equivalent to how much half-life of B. Then only you can work out the problem. How to approach this? For this you have been given this data. Simplify this. 3 T half of A equal to ln2 equal to 2 half-life of B is also ln2. Therefore, 3 half-life of A is equal to 2 half-life of B. Therefore, in this time, 3 half-life of A, it is equal to 2 half-life of B. Therefore, you have to put 2 power 2. Therefore, now what is asked? What is the concentration of CA, B, and C of B at time T after 3 half-life period? This is the concentration left at A at 3 half-life of A. And this is the concentration of B left after 2 half-life. 2 half-life because 3 half-life of A is equal to 2 half-life according to the given equation. Therefore, now divide A of T by B of T equal to C of A naught by 2 power 3 into, just to reciprocate it, 2 power 2 by C of B naught and it is equal to 2 power 4 or equal to 1 by 2 into C of A naught by C of B naught. C of A naught by C of B naught is given as 3 by 2 equal to 3 by 4. Therefore, after 3 half-life of A, your answer would be a 0.75. You may be asked, or in the 3 half-life of B, you have to work out how to work out it. And it will be somewhat difficult and you have to make use of it. For 2 half-life, it is equal to 3 half-life of A. For 3 half of this, 3 into 3 by 2, you have to use like that way. Such a difficult problem would not be asked. Don't be afraid of B. And the next one I am going to give it is equations here used that is T half of the half-life period is equal to 0.693 by K1. This is the equation provided the stoichiometry of the reactant should be 1. The stoichiometry is changed. Accordingly, these equations should also be changed. For example, if N of A giving the product, the reaction follows first order kinetics. If no N is there, the half-life of the reaction is given like this. If N is there, then the T half of such first order kinetics is given by 0.693 by NK1. If 2A is given the product, then T half for such a reaction is calculated by 0.63 by 2K1 and so on. Don't forget, which is already we discussed in the zero order reaction. It is also applicable for the third order reaction, second order reaction, and so on. And now we are going to see another type of problem. Take down the problem. A first order reaction takes 8 hours. The first order reaction takes 8 hours. For 90% completion, calculate the time required for 80% completion. Given bracket log 5 is equal to 0.7, log 10 is equal to 1. Option 7 hours, B 5.62 hours, C 4.1 hour, and D 8 hours. 8 hours. How much is the completion? For this type of problem, we have to make use of the kinetic equation for the first order. What is the kinetic equation for the first order? K1 into P is equal to log of 2.3 into log of initial concentration by the concentration after the time T. And here two types of sets are given. What is the two types of sets? For 90% completion, 8 hours is given. And for the 80% completion, time is required. So, direct substitution. It is you have to make use of this equation 2 times. K1, that is the K is equal to 2.3 into T into log of N0 by 80. This is the equation. First apply it for 90% completion, 2.3 in the 8 hours. For 90% completion, it is time taken is 8 hours. And in percentage is given, therefore initially 100% is present. 90% is completed, therefore what is the amount percent? It is 10%. This should be also equal to K1 because the same first order kinetic. This should be also equal to 2.3. And what is the time required for 80% conversion? Therefore, the time required, we put it as x into log of a naught 0, 100 by 80% completion. But 80 is the amount left, the remaining is 20. Therefore, if you make use of it, 2.3, 2.3, 2.3, that's cancelled. Therefore, 1.8 into log 10 is equal to 1 by x into log 5. Or log 10 is equal to already given, or otherwise you know your calculator. It will give you the answer as 1.8 is equal to 1 by x. Log of 5 you already know what is the value of this log of 8.7. Therefore, x is equal to 8 into 0.7 equal to 5.6 hours. You can make use of this equation for whatever may be the percentage of conversion or whatever may be the amount it is. If one set of data, the time required for this completion is given, you may be asked, what is the percentage converted in this time gap? Once again, you have to make use of this type of problem. In the zero order reaction, the same is written as K naught is equal to x1 by t1 is equal to x2 by t2. But here, you can't apply. There is no shortcut for this. I think you understand for this one. Next problem, you work out for this. In a first order reaction, A giving products, 60% of the given sample, 60% of the given sample of A decomposes in 40 minutes. In 40 minutes. What is the half-life of the reaction? What is the half-life of the reaction? For which once again we apply the same one. Here A is giving the product only one short term. Therefore, you can make use of this. First apply the data 2.3 for 60% conversion. How much time is required? 40 minutes. The log of percentage is given. Therefore, 100 by amount left. After completion, the amount left is 40. Don't put the 60 itself. It will lead to the answer. But don't be afraid. If you put 60, what is the answer? That will be also present in your answer. Therefore, you can joyfully tick that answer is equal to 2.3 by f into log of 100 by 50%. That is half-life is 50%. Therefore, now you get this one 2.3, 2.3 cancel, and it is equal to 2.5. And what would be the value of 1 by 40 in the log of 2.5? What is your calculator saying? Log of 2.5 out of log of 2.5. Approximately tell me the answer. Ready, reckless. 1, 0, 2.3, 3.48, 2.5 exactly at the middle. What will be the answer? Log of 2.5. Nobody else there?
0.39.
Oh, why are you putting this? Take it as 0.5. Therefore, the log is 0.4. You are doing approximate one. Right, Sana? You follow this. Then 1 by x into log of 2, 0.3. Find out the x. That way you can put whatever may be the percentage of conversion. If you are well versed in this, now work out this problem and find out the answer. Find out the answer. Find the relationship between T3 by 4, that is 75% conversion, and T15 by 16, relationship between for a first order kinetics. for a first order kinetics. Option T 15 by 16 is equal to option A 3 T 3 by 4. B T 15 by 16 is equal to 2.5 T 3 by 4, or C 0.5 or half T 15 by 16 is equal to T 3 by 4. D 1 by 3 T 15 by 16 is equal to T 3 by 4. Here fraction is given. You can make it into percentage and you can calculate. But if a fraction is given, you can make it as a fraction. How to approach the two set of the data once again. Once again, you have to make use of this problem. And here, once again, you have to, not in terms of percentage, because this percentage is easier. 15 by 60 percentage would be difficult. Therefore, make use of the fraction. If fraction is used, then initial concentration of A naught is taken to be 1. AT, amount left. Here, amount converted, 3 by 4. Therefore, amount left is equal to 1 by 4. Is equal to 2.3 by T 15 by 60 into log of 1 divided by the remaining is 1 by 16. And this is equal to 2.3 gets cancelled. Then 1 by T 3 by 4 into log of 4 is equal to 1 T 15 by 16 into log of 16. And 1 T 3 by 4 is equal to into log 4 is equal to 1 T 15 by 16. Log 16 can be written as 2 log 4. Do you follow this? How I have written 2 log 4? Hello?
4 square.
4 square. Bring the 2 here. Yeah. Now log 4 gets cancelled. What is the relationship between this and the T of 15 by 16? Bring in the upward, go to that side, 2 into T of 34, 2 times. What is the answer given? The answer is இல்லையா? The answer is காணோம். Option C. அவங்க என்ன பண்ணிட்டாங்க, அந்த ட்ரூவை இங்க கொண்டு வந்துட்டாங்க. Option C is the correct answer. You can calculate for any relationship between this, any percentage. And the next simplest problem. Take down the problem. Half-life of a first order reaction is 70 seconds. First order reaction is 70 seconds. Calculate the time taken for 75% completion of the reaction. 75% completion of the reaction. உடனே ஆன்சர் சொல்லிடுவீங்க. What is the relationship between the T 75% by T 50% for first order? For 0 order 1, and 1.5 second order, first order, it is 2 times in படிச்சிருக்கீங்க, ஞாபகம் இருக்கா? Therefore, what will be the time required for the completion? Anybody tell me the answer?
140 seconds.
140 seconds. Immediately you can tell this answer. There's another type of problem that may be asked. What is that problem that may be asked? Take down the question. For a first order reaction, A giving products. First order reaction, A giving products. The concentration of the reactant after 10 and 20 minutes, the concentration of the reactants after 10 and 20 minutes are 4 into 10 power minus 3 molar, 4 into 10 power minus 3 molar, and 10 power minus 3 molar, 10 into 10 power minus 3 molar, respectively. Calculate the rate constant and the T half of the reaction. Calculate the rate constant and the T half of the reaction. Here, initial amount is not given. So far, we have calculated so many fraction is reacted. The initial concentration is unity. So many percentage is left. We have taken is the initial concentration 100%. But in this problem, 2 time factors are given and the concentration is given, but not the initial concentration. Therefore, for which you have to rearrange the equation, and this reaction equation you have already seen in your physical chemistry problem, in the ester hydrolysis problem, I think so. What is that formula given? K1 for such a reaction, concentration alone is given is equal to, K1 is equal to 2.3 by, 2.3 by T2 minus T1 into log of A minus X1 by A minus X2. Or A is the initial concentration. The initial concentration A minus X2 அப்படிங்கிற கூட நீங்க என்ன செய்யலாம், A of T one time, A of T2 the second time. That is the amount left at the time T1, amount left at the time 2. அதைத்தான் நான் உங்களுக்கு என்ன கொடுத்தேன், A minus X1 and A minus X2 ரெண்டும் ஒன்னு. இல்ல இது ஈஸியா இருந்ததுன்னா இதை போடுங்க, அது ஈஸியா இருந்தா அதை போடுங்க. This is the amount left at the time T1 and this is the amount left at the time T2. Use this equation, you can easily calculate the K1. That's all. You can substitute it and you can arrive at this one. And shall we go to the next type of problem? For a first order reaction, A giving B, the rate constant is X per minute. If the initial concentration of A is 0.01 molar, X is 0.01. The concentration of A after 1 hour is given by the expression option 0.01 e power minus X. B 1 into 10 power minus 2 to 1 power e power minus 60x. C 1 into 10 power minus 2 e power minus 60x. And D 1 into 10 power 2 e power minus 60x. What is the correct expression for this? Here for the which type of problem formula to be taken? We know the chemical kinetics logarithmic form. We already know this. K1 is equal to 2.303 by T into log of A0 by AT. This is a logarithmic form. In addition to the logarithmic form, the exponential form is also present for the first order kinetics. What is that? The AT is equal to A0 into e power minus AT அப்படின்னு ஒரு exponential form equation is and also that therefore whether you have to take the logarithmic form or exponential form, see the answer in which form it is given. Accordingly, you choose your formula and substitute and find out the answer. Can you now find out the answer for this? Okay, shall we go to the next type of problem? For a first order reaction, the rate constant is 0.6909 per minute. The time taken for 75% conversion in minutes is 3 by 2 log 2 b 2 by 3 log 2 c 3 by 2 log 3 by 4 or d 2 by 3 into log 4 by 3. Work out and find out the answer, which is the correct one. Take it as a homework. Take another type of problem. The time elapsed for a first order reaction between 33% and 67% completion is 30 minutes. The time elapsed for a first order reaction between 33% and 67% completion is 30 minutes. What is the time needed for 25% completion? This is another type of problem. The difficulty was somewhat increased. What is the time needed for 25% completion? Option A, 150.5 minutes, B, 12.5 minutes, C, 180.5 minutes, D, 165.5 minutes. What is the correct answer? How to approach this problem? It can be easily approached, for which you have to find out what is the time taken for 33%, what is the time taken for 67%, find out the difference. That is equal to 30 minutes, from which what can be obtained. You can calculate what is the K value. From the K value, you substitute for the 25%. Now, let us work out now yourself. You can work T 33% or K1 is equal to 2.3 by T 33% is equal to log of, this percentage is given, therefore log of 100. 33% completed, therefore remaining 67. This is a K1T33. Or you convert it into this other way, this is equal to 2.3 by K1 into log of 100 minus 67. Similarly, work out for T of 67%. What would be the equation? Immediately tell me the equation. 2.3 by K1 into log of 100 by 33. Which would require higher time, or 67% completion or 33% completion? It require higher time.
67.
It is given that the time elapsed between 67% completion and 33%. Conversion is 30. Therefore, you have to put 2.3 by K1 into log of 100 by 33 minus log of 100 by 67 equal to 30. Can you now find out what is the K value? Now you have arrived at the K values. K1 is equal to how much? Bring this, run this 2.3 by 30 into log 2. Keep it as such. Not necessary to calculate some other things. Okay? Next one. We will go to the calculation for T of 25%. T of 25%, how much? That is equal to 2.3 by K1 into log of 100 by 25% is completed. Therefore, 75% is there. Or we can write it as 4 by 3. Podalama. Is it correct or wrong?
Yes, sir.
Am I correct? Okay. And for the K1, you have already worked out this one. K1, put the value of the K1 in that one. You would get 2.3 by K1 is equal to 2.3 into 30 into log 4 by 3 by log 2. This can be written now work out for this 2.3 gets cancelled and the remaining would be 30. This gets cancelled. Remaining would be 30 into log 4 minus log 3. How much? Log 4 minus log 3. How much? Divided by log 2. Log 4 minus log 3 எவ்வளவுன்னு சொல்லுங்க, சொல்ல மாட்டேங்கிறீங்க. What is the value of log 4? Point. Point 6. And minus log 3. Point 48. What's the difference? 0.12. Not? And 0.3, 30 divided by 0.3, how much? சொல்லுங்க. Thirty divided by 0.3. 100. 100 into 0.12. 12. Therefore, the T of 25 minutes is approximately 12. Why you are putting approximately 12? Say log 3, log 2, நம்மளுடைய computer, sorry, calculator சொல்லுது. Therefore, 12 answer here is B answer 12.5. We call it as a most difficult level question. But such a question so far is not asked so far. If at all it is asked, you should be in a position to work out this. This is the இங்க நம்ம 66க்கும் 37க்கும் 33க்கும் 67 37க்கு கொடுத்துருக்கோம். இதே மாதிரி 75க்கும் 25க்கும் கொடுத்துட்டு they may be asked to calculate 50% இதுக்கு என்னன்னு கண்டுபிடி அப்படின்னு கூட கண்டுபிடிக்கலாம். And this is the methodology you can adopt to calculate such problems. And we have not worked out any problems in second order kinetics and third order kinetics. Very few problems are present in the second order kinetics. Therefore, in the next session, we will see the second order and third order reaction problems. Then we will see in the same session the variation of the rate constant and rate of the reaction, rate constant, rate of the reactor with respect to temperature or the temperature coefficient of the rate equation. Then we will see the Arrhenius rate equation. These are our goal to be concluded or to be completed in the next session. Thank you very much. Have a nice day.